know what opponent did in the previous moves, but some cases are there where you don't even know how your player is. If you are playing a football match, it may happen that your player's right leg is stronger than his left leg, and you don't know which leg is stronger, and hence this will lead to different payoffs. If the player is of right leg type, striking with the right leg will give him a greater payoff than the left leg type, and you don't know what type of the player is. So this is our topic. So Aman will present the rest.
So basically these are the contents of this PPT. So first topic is like introduction to Bayesian games. So till now we are like dealing with complete, perfect, imperfect and these three things, but now we are entering into the field of incomplete information. So what does this mean? We have like two types. In Nash equilibrium, we are having only three things like NAU, but we are having type and probability of type and prior belief. So if one player is having two options like kicking left or right for an example, and player 2 doesn't know where he will be choosing, it's about the nature. So every player has a different type. Example is like player might be aggressive or defensive, or we can take like two multiple strategies, like if he is playing prisoner's dilemma or other strategy. And next is like every player has a player belief like about opponent. So different types of games. We have perfect, imperfect and incomplete games. Perfect information, like I know everything that has happened and everyone's payoff. Imperfect information means like I don't know what opponent did in the previous moves. And incomplete information means I don't know my opponent's payoffs. It is like this is the first, intermediate and third one.
Basically, what is happening here is that player 1 is of two types. He is of A type and he may be of B type. And player 2 is only of single type. Player 1 knows whether he is A type or B type, but player 2 doesn't know. And that is why player 2 will form a belief that I believe that there is a 40% chance that player 1 is A type and 60% chance that he is a B type. So player 2 has to make some assumptions about player 1 and then he has to. So that is why we are getting two matrices for this type of case.
As of now, like here, if you are seeing like player 2 is a single type and player 1 has of two types. Like choosing left, right, I mean, it's like two strategies, like prisoner's dilemma and other thing is like cooperating game, if you think like. So, player 2 doesn't know like whether he need to choose left or right accordingly. For example, like single type means he doesn't have other option like two strategies according to player two.
Player 1 knows that player 2 is of single type, means he knows perfectly that he is only right leg. But player 2 doesn't know.
So now I want to introduce Bayesian Nash equilibrium. So it is like Nash equilibrium plus type plus belief. So if we see here, like if you remove the blue color one, it will be the definition of Nash equilibrium. This is the differentiate between both Nash and Bayesian. So here we are including type plus belief, and if probability also can be chosen. Now the topic is like how to solve this problem. So basically in Nash equilibrium we try like eliminating the non-negative factor. So we can try that method. Let us say like we have two pairs, A1 and S. One is two types, like and type. So player two will be having some condition that is to be less perfect. So player one have for example, in first case, for player left dominates right. And in second, the player right dominates
See, sir. If we consider the A type for player 1, if player 2 assumes that player 1 is type 1, then right, left is a strictly dominating strategy. If he assumes that. But we cannot remove like right yet.
And in second case, like we can be we will be seeing like right is dominating the left. So there is a confusion in player two, like whether to choose type or and whether to choose right or left, because you don't know like player one is choosing type A or B.
Player 1 can be left to the right foot. Player 2 is single foot or left to the right. So player 1 has some issues on player 2 has some issues in like knowing whether player 1 is left or right. Based on that, like
And like for each type we are having he will be assuming some probability, like he's choosing P probability and other type with 1 minus P choice.
If he assumes that player 1 was A type, left was his best move. But he cannot remove right yet. Player 2 cannot remove right yet. Why? Because if it turns out that player 1 was B type, then right will be his best move. So what to do? He cannot eliminate any of the strategies.
okay, basically like what if player 1 is type A, so the graphics. Okay, wait. So the both the
Those matrices are discussed now. But here's the question. 3, 4, 1, 0, 4, 3, 2, 0.
In first case, like this is dominating the left domain.
Let me change the color of this. Now is it visible?
Like in first case we can see like left is dominating the right for player two, and in second case right is dominating the left. So there will be confusion for player two, like whether to choose A type or B type. He don't know like player one is choosing whether A or B. So he don't have any choice like eliminating the picks. So it is like the example for single strategy, like single type strategy. If you look for type, I mean player one, In type A, like down is not dominating, I mean dominant strategy, and in type B it is up.
So that here is the difference that player 1 can remove because he knows whether he is A type or B type. So he knows which type he is, so he can actually remove the dominated strategy. But this was not with player 2.
So in this case, we like apply the mixed strategy, like giving some probability for type A and type B, calculating for viability of player 2.
What is the difference between this mixed strategy and the previous mixed strategy?
So like here we don't have complete information, like incomplete information. So whether to choose. So there we have like only single matrix. Here we have two matrices.
But there is the problem that here these are different. That time when we calculated T, we would see that player this would play left with probability this, and player 2 will play right with probability this. We would say something like this. But here T are different. When we calculate T, we will say that player 2 will play left. Player 2 will play left if he believes player 1 to be A type with this T probability. This is the difference which we are doing.
So
This is
there
the belief probability, not the choosing probability, like I will choose left or right. This is the belief probability.
So we solve with probability and apply the mixed strategy. So if we look here, like if P greater than 2 by 5, he will be choosing left most probably. The conclusion is like hence player 2 has two choices. He believes player 1 is A type and plays left with probability greater than 2 by 5, and he will play right if he believes player 1 is A type with probability less than 2 by 5. So this is the conclusion, like player 1 plays down if he is A type. He has some clarity like whether to play up or down, but for player 2 it's not like that. It's depending upon completely on player 1 and another player what the type he is playing. So we have a strategy for each type of player given their beliefs about others, and no one has incentive to deviate.
We have a strategy for each type of player. Like we have type A, strategy for type A also, type B also. Given their belief, and no one has incentive to deviate. So this is what we call as vision map. What will be the strategy?
It is like Nash plus type and probability and prior belief. From here the dimension.
Sir, do you have any confusion till now? Because we are moving ahead, so
Do you have any confusion?
yes.
Can you look last two weeks have any confusion?
Which slides?
Just like
This one?
yeah, this one.
Like
I don't know about anything about player A. I will believe like he is 50-50 of type anything.
no. See, you have a strategy for player 1. Player 1 has a strategy that I will play down if I am A type. Because player 1 knows.
No, I am player 2.
You are player 2, I am player 1.
Yeah.
What I will play? I will play down if I am A type. Because I know what I am. I know my nature. What about you? You are player 2. You will play left if you believe that I am A type with a probability 2 by 5. 2 by 5 means 40%, right?
But
If
I would consider like probability is 50-50. I will consider that.
that, yeah, that is your belief, na? You will consider 50-50.
That's the difference. What they are doing is like in the mixed match, it will be like conventionally it will be what we discussed. There it's like it's not belief, it's like confusion, randomization. Because of this, like we play in such a way that to neutralize the other person. Here the thing is like one person is definite. One person is not going to have probability at all. The other person doesn't know like which is going to play because he has two options. You understand? It's like player 1 has I think like option. Okay, to play either like this type or that type. Player 2 doesn't have any. He plays only one strategy only. But the thing is like player one has two choices, right? But like player two doesn't know which choice player one is going to play. But reverse is not true.
What you were saying that
Reverse is not true. That's why like that probability was based on what you are going to play. This probability is based on what the belief is. I mean, if I believe like he is left-handed, with left footed or left thing, I will going to have a probability with this something. Okay, it is based on some belief.
So you are saying like we won't consider the options to be equally likely.
Yes.
yes,
Like upon our belief, we will say this is more likely or likely.
Yes,
Or else,
yes.
okay, wait. One minute. Here that's what I told you, right? Like here you are not neutralizing. There we were neutralizing. You understand? Because of like to make the other person indifferent, you found out and like it came for point. Here the thing is like you are predicting. There you are analyzing and like pinpointedly because of the utilities, you are able to like neutralize. Here you are just having some belief. Okay, this belief also like one thing is like how do you know like which one that you play? Player one has to right? Player one like with what probably like he will play. Then only like your belief like you want to update, right?
sir, belief is a prior belief. No? I have seen him play sometimes, so I have a belief that suppose he said that 50-50. I have a
That's
chance
not like,
that
it's like proper prediction.
Ah.
I predict like he will play 7 out of 10 times left or like left footed, 3 out of I'm just predicting it.
since you said that I will say 50-50, so you are telling that player one, I believe that player one is A type with 50% probability. And what you got? You got that 50%, right? So 50% is greater than 40%. So you will apply this thing, greater than 40%. At greater than 40%, if your belief is greater than 40% for time A, what you will do? You will do. This is what you are doing. You have to have some belief, prior belief about it. And what you are getting is, like, what should I do? Means, what will be the limit of my belief that I should play this or this? This is what you are getting. Any else? Anything? Yeah? So, now we
The
are moving.
probability that like a question from this chapter is going to come in mention. What would be the probability in your belief that like a question from the same question with some twisted problem values is going to come in answer?
Yeah, this is advanced.
Well, still I'm telling you. Zero, you want zero belief. This is it.
So, now, what?
One is already working on problems. Right? We're already working on problems here.
Now,
Yeah, with jokes apart, please listen. Please understand, like, when you were on this page, like, they were all listening, right? Okay. Please do the favor back.
now, what if you also don't know what your type is? How is this possible? Suppose you are playing cards. Some cards were served to you. And for simplicity, let us assume that either you will get 4 A's or you will get 4 Jacks. For simplicity. So, since the cards are just now served to you and you have not washed your cards, you don't even know your own type. So, even before knowing your own type, you may have formed a strategy that if I get this, I will do this. If I get this, I will do this. Before even knowing your type. So, so we get 2 types of dominating strategies. If you don't even know your own type, and then you are making any strategy, if then you are getting any dominated strategy, that dominated strategy will be called as ex-ante-dominated strategy. Before even knowing your own type, if you are removing one strategy that this is my worst move, that strategy will be known as ex-ante-dominated strategy. And when you see your cards, you know that you have now become type A, and at that time when you are removing some strategy, that dominated strategy will be known as interim dominated strategy. Okay. So, this is the example of cards. Before the game was started, you did not know which cards you are going to get. You did not know your own type. But still you may have formed your strategy without actually knowing your cards. And this is anti-dominated strategy, and when you will actually see your cards, your strategy might change. Okay. And this concept leads to two types of dominance, ex-ante and interim dominance. So this is the definition of ex-ante and interim dominated strategy. Strategy for see one thing. Here I have stressed about the player because we don't know the type yet, and here I have stressed about type because now you know the type of the player. So first, let us see how to find interim dominated strategy because it is slightly easy to understand. So here we can see that left is strictly dominated by right. Okay, here player 2 is of two types. One more thing here. Here we have taken the example of player 2 to the two types. Okay. Now, if player 1 knows he is the A type, then he will left is strictly dominated by right. So he will remove left, and if he removes left, it will be known as interim dominated strategy. Here we do not have any dominated strategy, so no interim dominance here. Now, how to find ex-ante dominance? Because means you don't even know your own type. So for that, you need to form a bigger matrix first. How to do the calculation? Left A, left B, right A, left A, right B. Like this, you form the bigger matrix. Then you multiply the probabilities here with the utilities, with the corresponding matrices. Here we multiplied with 0.8 because the probability was given as 0.8 for this problem, and there it was given as 0.2. We multiplied, and then we will add them and write here. This is how we will complete this bigger matrix. Now in this bigger matrix we will find out which is our dominated strategy. So we can say that left A, left B is strictly dominated by right A, left B. So this type of dominance is ex-ante dominated strategy. And left A, right B is also strictly dominated by right A, right B. So these two are the examples of ex-ante dominated strategies. Acha, what does this right A, left B means? What does this mean? It means that you formed your strategy before even knowing your type. When you will see your cards, you will know your type. No? So at that time you will decide that okay, I will play right A. I am A type, so I will play this. It is like after knowing your type, you will be sure which you are A type or B type. And you can find the equilibrium also, and this equilibrium will be known as ex-ante equilibrium, ex-ante Bayesian Nash equilibrium. And one more thing I want to show you, that there is a theorem see, left was strictly dominated by right. We got as an interim strategy, right? So here also you will get left as strictly dominated. Left A is always strictly dominated. See, right A strictly interim dominates left A. We got this in A type game. So wherever there is right A here, right A, left B, and left A, right A always dominates left A. That is why we were getting this thing. See, right A always dominates left A. If a strategy you found out to be interim dominated, then it will always be X anti dominated. Right A will always dominate left A, given that this thing is this. This will always dominate this. And right always dominates this. Right A will always dominate left A, given that this is so. This is what we want. I have written also this here. If a strategy is interim dominated, then it is also X anti dominated, but the converse is not. And that's it.
Which led to using a couple of 50 minutes. Only single person, 50 minutes in the middle, right?